All right. This is a bit of a long problem. We're given a reaction mixture. This is in two parts, so I'm going to call it part A and then part B. Reaction mixture initially contains amounts and then an equilibrium. And then we have a second reaction and we're given initial concentrations and we want to know the equilibrium concentrations at the same temperature here in the second mixture. So when you're given only initial concentrations and you want to find equilibrium, you have to know what K is. If you notice, it doesn't give us K at all in this problem. So that's a situation. We need to deal with that. So why don't we write our expression for K, because we're dealing with the same reaction here. What do you notice? That doesn't count. So H2O, yes, water is a gas in this scenario, so it still counts. You just eliminate liquids and solids. SO2. Okay, so there's our expression for K. In this case, so this here, I'm working on part A. We're going to try to find K here. It doesn't actually ask us to do that, but we're going to have to in order to answer the final question because we don't know what K is. So we're going to need K. So that's what we're going to find. So let's write our reaction. Let's make an ice table. All right. Now, remember the S doesn't count because it's solid. So just either don't write it on there or mark it out like I did. Initially, we have 0.5 molar of each of these. And it doesn't say anything else initially. And then it says this is how much we have at equilibrium. So if we don't have any there, so this is gaining. Copy your coefficient. Be careful here. So these have to be losing. All right. So now let's solve for x. 2x equals 0.0011. So x has to equal, we need to divide that by 2. 0.000055. Yes. 1, 2, 3, 4. 1, 2, 3. Nope. Put an extra 0 in there. It's like, no, it's too many zeros. Sorry. 1, 2, 3, 4. There we go. All right, better. All right, now, anywhere there's an x, you put 0.00055. Here there's 2 of them, so 2 times 0.00055. Go ahead and subtract 0.5 minus 2 times that. 0.4989. And 0.5 minus 0.00055. And 0.4995. Why not? All right, so now let's plug into our expression here and solve for K. 0.11 squared. 4989 squared and 0.4995. Again, how you round, gonna be one way or the other. Okay, 0.0011 squared. Divide by 0.4989 squared. Divide by 0.499. Okay. So we get 9.73 times 10 to the minus 6 for K. Okay, so we're going to need that. Now we can do the second part and our second reaction. I'm not going to rewrite this equation. I'm just going to make another ice table here. If you want to rewrite them, that's fine. Oh goodness, I drew that line in the totally wrong place. If you want to, that's fine. But see, this is how you can do stuff. Okay. Okay, now, initially we have 0.25 and 0.325 and nothing. So make our stoichiometry there. All right, now don't use anything with these concentrations because those don't matter anymore. So at equilibrium in our second reaction, minus 2x, 0.325 minus x, and 2x. Next thing, solve for x. So we need to use our k value. K equals 2x over 0.25 minus 2x, 0.325 minus x. All right, so this can be an absolute disaster of a quadratic. Do you see how this is small? I bet we can probably use an x is small. So take one of these. Generally, you want to take the smaller one. You can do it with both of them, but it'll work. Take the smaller one, 0.25. So let's check m over k. Is it greater than 100? So the smallest molarity divided by 9.73, 10 to the negative 6. You're going to go, of course it is. So check. So that means x is small. We like this. All right. So that makes things way easier. So 0.25 times 0.325, 0.08125 equals 2x. Oh, curses, that's squared. I messed that up. I was like, I messed something up, sorry. Put your equilibrium there. All right, hold on. Times 0.25 again. Okay, 0.0203 equals 2x. This is also squared. So, man, get into a lot of problems when I don't copy things correctly, so that's 4x squared. I'm also used to doing acid-base reactions where you don't have to do this as much. All right, so now that I have squared things appropriately, and so now we need to divide by 4 and take the square root. So x equals 0. Oh, good heavens. I'm messing this up all over the place. Instead of k, we already said k is small, 9.73, 10 to the minus 6. All right. Let me try this again. 9.73, 10 to the minus 6. This is why it helps to have y'all in class with me. Helps me out. 0.25 squared times 0.325. Y'all wouldn't let me do that silliness. 1.97 times 10 to the minus 7. There we go. Now divide by 4. Now take square root. I was like, I'm going to get some crazy big answers here when I don't need to. All right, so we should get 2.223, if you want to put that in there, times 10 to the negative 4th is x. This wants to know the equilibrium concentration of H2O in the mixture. So concentration of H2O equals 2x. So 2 times 2.223 times 10 to the minus 4. Go ahead and put your molar on there for your concentration. So you get 4.446 times 10 to the minus 4 molar. All that work for one number.